Okay, hello, hello, hello. A little bit of an early start here, at least before we start class, anyway. Hello, hello, hello for those people who came in a bit early. How's everybody doing today? Hello, hello, hello. Actually, tonight, this evening, yes, question mark. Hopefully everybody's doing really well today. Everybody doing pretty good today, I hope so. See some people in the chat already. That's good, that's good. Hey, Ujwal, how are you doing? Doing good? Good. Good to see you guys. Hello, Beth. Beth, great to see you. I'm glad you're doing really, really well. Wonderful to see you this evening. All right. I know that things may be a bit cold outside, but hopefully you're nice and warm in your own homes, and you're, hopefully enjoying this lovely, lovely day. Guys, tell me you guys got plans for the weekend? It's gonna be very interesting, that's for sure. It's following the market today. That was a lot of fun to watch. Hey, how you doing, Susan? How you doing? Things good with you? I'm doing really, really good today. I hope you're doing good. Good. Wonderful to hear. Wonderful to hear. We got a nice evening ahead of us. Hopefully, we'll learn a little bit along the way. Um, we're nice ahead of yeah. Try that again. We're nice and ahead of the curve. Really good. Tesla during after hours. Yes. This man's invested in Tesla. Of course, I'm watching after hours. I'm gonna probably win a little bit. I'm probably gonna lose a little bit on Tesla. So yeah, their earnings call came in after the bell today. Oh, you were invested in Tesla too. Okay. Glad we have a similar mindset. Yeah, so they have more revenue. They are more profitable, right? Not more profitable, but they got more revenue, even though they're not as profitable, because their businesses, they had to spend more to make their businesses run. So people are kind of looking at it with a double-edged sword. It may be too expensive for them at the moment, but they did make more money than last year and are actually profitable as a car company for the first time ever. So there's a couple ways to look at their earnings reports at the end of last year. So there are positive signs that the company is going to grow in 2021. But if you think about it, it's kind of crazy in the middle of a pandemic. Like, that's Tesla. Tesla's the most unique company that you can ever run into. At least it's not GameStop today. GameStop, holy smokes. GameStop, wow. You want to see how crazy things are right now? You can see it. Here's a look at Did I hear about Michael Burry shorting Tesla? Yeah, that's pretty expected. Um, that's pretty expected. Michael Burry shorting Tesla, pretty expected considering that's his. He's kind of he's a big shorter anyway. So I mean, there have been so many people who've been shorting Tesla for quite a long time, and they're going to continue hawking the fact that yeah, Tesla doesn't have any fundamentals and whatnot. I tend to disagree, considering you're now part of the S&P 500 that comes with some qualification. You do have market share in the electronic vehicle market. You also have other businesses in Tesla, because Tesla's not just electronic vehicles. Tesla has, when people think Tesla, they think electronic vehicles, but you forget, SpaceX is also underneath the umbrella of Tesla. Their battery making factories. They have their solar panels and things like that. They have the solar roofs and whatnot as well. So you have a lot of different types of tech that are thrown into Tesla underneath the big umbrella that is Tesla. So it's not just like just one thing. It's actually many things kind of wrapped up into one. So I can't really say shoring the company would be the best idea, considering it has hands in a lot of different things. So it is a tad overvalued. I'm not going to lie. It is a tad overvalued, but you can buy into the future of the company because of the amount of technology it's going to pump out. Hey, Natty, how are you doing? Grant, good evening to you. I hope you're doing well. AMC, I bought 9 shares of AMC. Just 9. I was like, okay, I'm going to throw $100 or $150 into AMC, and I'm just going to see what happens and ride a wave. I'm like, I don't care what happens to it. It's not going to hurt me too much. Today, yeah. Hey, Susanna, how are you? I hope you're doing well. Hope you're doing really well. Good evening. Good evening to you. So yeah, I bought 9 shares pre-market today, and I just kind of let it ride. I don't really care. It's like a couple hundred. It's like $150. It's like, you. Let's see what happens. 9 shares isn't real. 9 shares, $150 isn't really going to hurt me too much overall. Tesla going down is going to hurt me a bit, but let's hope that I can get back the money again. I'm going to have to re-strategize. So rich guy, no, I'm not rich. No. I have some extra spare money, but I'm not super rich. Trust me on that. I don't actually spend a whole ton of money, surprisingly enough. Except on food. Yeah, that's pretty much it. I just spend on my bills, and that's pretty much it. It's not that I'm super frugal, it's just I don't have a lot of things to spend on, to be perfectly honest. So the only thing that I am doing, in all honesty, is paying my mortgage off. So I'm paying off like an extra $500 on my mortgage every month, which is like double my mortgage. So I figured I could get my principal down faster. So why not? If I can be able to help, though, I mean, that'd be a good idea. Can't really argue with that. My. Let's see, where is Tesla right now? Tesla at 6 o'clock. Let's take a look. Tesla 6 o'clock, 8:23. Okay, that's fair. That's fair considering earnings results. So hopefully by the time it opens up tomorrow, hopefully it's floating around 8:20, 8:30. If it is, then I can I can do good things. I can at least mitigate some of my losses. Anyway, that won't be too bad. Okay. That ain't the worst thing in the world. All right. All right, Yusuf, my dude, how you doing? My day today has been great. How's your day today, Yusuf? I hope your day was good as well. That's what I'm hoping for, my dude. That's what I'm hoping for. All right. Who's ready to get started? Yeah, I hope you guys are ready to get started. Because, I am. Question mark, question mark. Let's do this. Hey, all right. Okay, let's go ahead and do this here. All right. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we are going to pick up where we left off last time. Last time we finished all of chapter 1. All right, and we talked about all the definitions, all the good stuffs there. So we finished up everything. We did. Your day been good? Very good. I'm very happy to hear that, my friend. Very wonderful to hear that. So last time we talked about chapter 1. We finished up the definitions and stuff. We'll be, of course, using some of those definitions here throughout the course of the semester. But today we're actually going to be doing the actual numbers parts. The numbers part actually starts today in some form or capacity. Okay, we're getting there already. So hopefully we'll finish up most or all of chapter 2 here today. Um, as it is not the biggest chapter in the whole wide world, we'll talk about that here. And then we'll go ahead and take a look. We'll take a look at some examples of this kind of a thing. All right, so let's go ahead and take a gander here today at the big board. All right. All right. Push that off here. All right. So, today, what we're going to be looking at is we're going to be looking at sections. First of all, look at this first handout here, which is sections 2.1 and 2.2, which is going to be frequency and frequency distribution. So we're going to take a little bit here. Sam Gates, hello, mate. Hey, hello to you too. I hope things are well for you, my friend. I really do. I legitimately hope things are very, very well out there. Um, Pretty late over there. It's midnight over there. If you're out in England, anyway. Okay. So let's talk about the definition that we have here. What is frequency and frequency distribution? So first of all, let's talk about frequency. Frequency is how many data items fall within a particular class. Now, class is another way of saying category, but I have a reason why I'm saying class here, because if we were going to look at some definitions regarding class, so you'll see exactly why we call it class here. We do have some definitions we'll need to go ahead and expand upon. What is this you're doing? I'm doing some statistics, my friend. Some statistics. So, all right. Next, let's talk about frequency distribution. A frequency distribution is basically going to be a chart, basically a chart in which shows all the various classes and frequencies associated with them to represent the data set. So what we're going to be looking at here is we're going to actually be looking at a data set, all right? So a group of numbers or objects or whatever. And we're going to be organizing them into a frequency distribution. So pretty much chapter 2 is going to talk about organization of data. Okay, because we want to be able to look at that data in a much easier capacity than maybe just a collection of just random numbers or random objects or whatever. Okay, so that's essentially what we're going to be doing here in this case. Now, what I'm going to be doing here for primarily this entire handout for 2.1 and 2.2 is we're going to go ahead and to answer every single one of these questions, we're going to just do one example because this one example can cover all these questions here in some form or fashion. So let's go ahead and do that right now. Okay. All right. Go. All right, so let's bring out the little paint tool here because we'll need this guy for us to come up with a nice example here. All right, let's do it. All right, so for our example here, let's say, for example, we're going to come up with a data set here, and let's take the easiest path here. Okay, let's say this data set is going to be test scores. Okay, so let's say they are going to be test scores. So we take some students, they took a test, we record those test scores there, and this is the list of scores that we got here in no particular order. Okay, so let's go ahead and list these down. So let's let's see, 67, 83, 92, say 51, 99, 81, 77, 3, another 77, 60. Let's see here. 91, 2, 88, 63, 70, and 93. Okay. So let's just here we go. We have ourselves a data set. Again, just random numbers, just kind of thrown up there, and that's perfectly fine. Okay. So in this case here, this is just random numbers. We're just gonna write down bada bing, bada boom. Got it. All right. All right. So let's go ahead and put this down here. All right. So what we're going to do now is make up classes here for each one of the things that we see here. Okay, so we're going to make up classes here in this instance. Now, what are those classes? Now, those classes here are going to be, say, typically if we talk about grades, we talk about, say, A, B, C, D, F. Okay, we say, okay, well, what grades got A's, or got B's, got C's, got D's, got F's. Now, in this case here, normally that would be okay, but let's say we're not actually attaching a grade to it. Let's say we're just finding out how many grades are in each particular category, like how many grades are in the 50s or in the 60s or in the 70s, 80s, and 90s. Okay, so we're gonna put it that way here. Now there is a particular reason why we're gonna put it that way, but let's go ahead and take a look at how this is gonna work. So first of all, let's take a look at the scores here. Um, we're gonna put first of all, let's take the 50s here. So let's put 50 to 59. And we'll put 60 to 69. Get 70 to 79. 80 to 89, and then lastly we'll have 90 to 99. Go. All right. In the next column over, we're going to put the frequency. So, so, So based on the definition that we have here, looks pretty small. Why do my letters get small? Okay, no sense, but fine. All right. So the question is that okay, frequency just means how many data items in the data set that we're given here. How many of them are going to fall between the scores of 50 to 59? So how many of them are going to be how many scores do we have in the 50s according to this data set? All right. So can anybody tell me here? Let's take a look here. How many data items in the data set? How many scores in this data set in this context? How many of them are in the 50s? How many of them are between 50 and 59? A Okay, you say one versus one. See what other people think. How many data items in the data set are between 50 and 59? All right. Okay. All right, so that's correct. The answer is indeed one. All right. There's only one test score that is between 50 and 59 in this data set, that being 51. Okay, so no problem. Easy peasy, lemon squeezy. All right, let's take a look at the 60s. How many scores do we see here in the data set are in the 60s? All right. Looks like we got three. Okay, that's correct. So we have 67, 60, and 63. Those are our three scores that are within the 60s. Okay, so that's perfect. All right. Let's look at the next one here. How many scores are going to be between in 70 and 79? So how many scores are in the 70s according to our data set? A lot of people saying four. All right. So that's correct here. Four is absolutely spot on. All right, we do have four scores in the 70s here. So we have 77, 73, another 77, and a 70. Oh, that's okay. That's why we go through these carefully. That way we can see. Sometimes you tend to skip one, so that's why we just go through the data set carefully there. Just count it up. Um, all right, how many scores in the 80s? What's the frequency for the 80s? How many scores in the 80s? All right. So you guys say three. I say, yeah, totally agree. Three is definitely your friend. And how about the 90s? How many scores are in the 90s here? Okay, that's correct. There are five scores within the 90s. That is correct. So nice and top heavy here, at least in this case. But yes, the five scores here being 92, 99, 91, 92, and then finally the 93. That is five scores that are in the 90s. Okay, so that's what we have here. All right. And so now what we've effectively done is built up a frequency distribution for this particular data set. That's all that really that first question is talking about here, is essentially that. Now, I'm going to go split screen here for just a moment. So let me do that. Now, I do need to make one very important note here, so I do want to talk about that from what you see here on the screen. And that is one of the things that's going to be very important for us to note is that to make sure that you did indeed construct the correct frequency distribution, um, if you add up all the frequencies together, like you see here on the screen, like 1 and 3, 4, 3, and 5, if you add up all those together here, those should equal the number of data items in the data set. So again, here we have 16 test scores here that we listed down. So if we add up all these numbers here together, this should also equal 16 at the end of the day. Okay, so sum of the frequencies uh, should be same as the number of data items in the data set. All right. If you find yourself to be one off in some capacity, go back and take a look at it again and make sure you got yourself squared away in that regard. Okay. All right. Good stuff. All right. Are there any questions about that before we move forward? Any questions at all? No. Okay. Any questions? Again, type no in the chat if you'd like me to move on, or if you do have a question there, go ahead and type out your question in the chat as well. Yeah, he's like, no. All right. Yeah. Hydrate, 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 hydrate. Do I have my thing? Oh, I left it. Okay, hang on a second. Give me. I'm gonna do the be right back thing. Give me a second. All right, hang on. All right, sorry about that. Okay. Now, I know. like it's like I got the worst. I got the worst pajamas ever. Okay, so like, I'm not sure you want to watch the worst pajamas ever. All right. All right. So I do have a drink of the day. All right. So, well, maybe drink for a few days. So today I have unsweetened bold green tea to hydrate off of. Okay. So I got a nice 2 liter bottle. I've already drank out of it. Has the caffeine kick that you need, just a smidge. Right. And it's nice and unsweetened, and it's a green tea, so it's a nice detox for those things that you eat earlier, like your Burger King, Taco Bells. So, yum indeed. Guilty pleasures, 1000%. So there's your hydrate there. We have to justify what we're going to hydrate over, so that's kind of a thing. That's kind of an important thing. All right, thank you, Daddy. Appreciate you. I know I got another type of tea there in the fridge that I bought from Mitsuwa. So but today's choice was Koicha, some unsweetened bold green tea. It's a bit bitter. It doesn't have sugar, but it's really healthy for you because of that fact. So there you go. Mitsuwa is awesome. Mitsuwa is like my second home for like amazing stuff. Long live Mitsuwa. Oh, I love Mitsuwa. Yeah. Yeah, see, they know me at Mitsuwa by heart. I walk in, I go over to the ramen shop, Santoka in the corner of the food court, and then I could just walk up and they could just write down the order, and then there you go. And then there you go. Oh my gosh, it's Milky. How are you doing, buddy? How you doing? This is almost as popular as AMC, Nokia, and GameStop at the moment. Too true, my friend. Too true. How you been, my friend? How you doing? Good. Yeah, I'm doing good. We're in the doing some statistics, my friend. Have I tried kombucha? Yes, I have tried kombucha. That is some good stuff right there. I love me some kombucha. I love let's see, pomegranates, blueberries, kombucha. Healthy teas are pretty healthy teas. I like, of course, you gotta have a little sugar in your life too. So of course I sometimes have. This stuff goes away so fast because of how fast I drink this stuff because it's too addictive. Like it's royal milk tea. Royal milk tea definitely. There's 25% milk, and then the finest blend of that black tea. Let me tell you, you drink it with your pinky there. Gotta keep up with this from it. Very good. Very good. Milky, thank you for the follow. That's really appreciative. Um, Milky, you're a god on James's channel. I appreciate you very much, buddy. You're so nice to me on that channel. I really appreciate it. Same with James. You guys are both amazing people. And then I bought this. And then I bought this here. I bought the Cafe Olay. This is for it's like kind of a milk cream coffee-ish type of drink here. This tastes wonderful too in a bottle. So can't go wrong with that. And then I probably showed you this the other day, and that was the green tea matcha stuff here. So yeah, good stuff there. Good bottles and drinks. All right. Yeah, Milky, just sit back, relax, and have a nice time. That's what it's all about. Hopefully, you learn a little bit along the way. Talking about some frequency distributions. There you go. I have good taste. I appreciate you. You have good. Hey, look. You have good taste as well. Okay, Susan. Okay, you and I, we're on the same wavelength here. Okay, your good taste didn't change from a couple years back. So there you go. We're all good. Oh my goodness, it's Jade. Hey Jade, how you doing? Thank you for the follow. Thank you so much. It's very kind of you to come in. Hey, see? Continuity, it works. Ha ha. For some reason you decided to re-sign up for my class and this is what you get. Okay. Look at the power of what happens when you re-sign up again. Feel bad about not following? Hey, no, I'm just glad you come in and just enjoy your time. That's it. I if you feel I deserve your follow, then I do. If I don't, I don't. But that's okay. We're chill. We're all one big happy family over in James's channel. No problem. You're always welcome in here. And if you learn something along the way, Jade, just like Milky, hey, I'll be more than happy that I at least affected your day in a positive way somehow. Okay. Let's talk about the next part here. All right. Very good. How very transcendental of you, Milky. Uh, all right. How do we calculate relative frequency? Let's talk about that here right now. All right. So, Relative frequency here is going to be a formula, and this is going to be important based on the sum of the frequencies that we just talked about here in this example. So we're going to use this previous chart here, and we're going to get to the next column over. But what's the formula here? So we're going to just take the frequency in the class, okay, so in that category, and we'll divide that by the sum of the frequencies. Again, as we just stated here, the sum of the frequencies is equivalent to the number of the data items in the data set. All right, so let's go ahead and take a look at how we can construct a frequency distribution using this here. Now, we are going to want to specify it in a particular way here. So let's go ahead and take a look at our example here. And let's make this a tad bit bigger now. I need a bit more space. So let's make a bit more space for giggles. Okay, maybe not uh, for science. For science. All right. Science. All right. Next, let's put down relative frequency here. All right. Okay. Here we are. Let's go ahead and put in relative frequency here. Now, what we want to do here is we're going to take our formula here in this case. We're going to take our frequency here. So we say in this case, we have one score that is between 50 and 59. All right. And so what we're going to do is we're going to take that 1 and we'll divide it by the sum of the frequencies here, which we said, again, said there were 16 data items in the data set. Take 1 divided by 16. Now we're just going to do this on a calculator straight up. Really not too hard to figure out here. But what I do need here specifically in this case is I do need the decimal equivalent here in this instance. So do we have a decimal equivalent here in this instance? So again, on your calculator here, just do 1 divided by 16. And can you get anybody tell me what's 1 divided by 16 here? We'll go ahead and met that out. Divided by 16 is as a decimal. All right, 0.0625. All right, that sounds perfect to me. All right, so that's exactly what we're going to put down here. Okay, so I'm going to put two things down here. First of all is the decimal equivalent, which you guys are correct about, 100%. Awesome sauce. Now we're going to go ahead and actually uh, put this into a percentage as well, because again, if we put it in a decimal, we can also put it as a percentage. So this would be equivalent to 6.25%. Okay, so you'll see why I'm exactly putting it now. Actually, I should tell you why right now is because some problems on the homework here ask you for a decimal and some problems will ask you for a percentage. So I'm just listing both here to kind of cover the basis for what you may see for the homework assignments. So if you do see those in some form, in some capacity, then you'll know exactly why that's happening in that way. Okay, let's take a good look here at next one. Let's look at 3 over 16, right? You have scores in the 60s. There's 3 of them. 3 out of 16, so 3 divided by 16. What do we get as a decimal in that case? 3 divided by 16 here. Three over 16. 0.1875, okay? All right, so I'm going to write down this decimal here, 0.1875, and we'll go ahead and put that as a decimal here. That's okay, buddy. No problem. It's all good. I know what you meant. I know what you meant there, camera. I know what you meant. I'm we all have our mistypes. It's all good, buddy. You're like, I'm trying to get it in. Come on. And then you're like, I messed up. And that happens like with me and Tesla today. Like, I want to get it at a higher price. Come on. And then it's like, oh, your earnings aren't as great as they said they were. Okay. I'm like sadness. It's like, come on, Tesla. Yeah, let's go. Let's go. If hey, look, if I have to take a little bit on the chin, you take a little bit on the chin and you move. You move on because that's just how it is. That's just how it is. It's like, okay, you know what? You have to take the good with the bad, the losses with the. You have to take the losses with the. Everything's got to be good. Is this stuff used for histograms? It certainly is, Milky. We're gonna get to that. We're gonna get to that. Chartley is talking about histograms and whatnot. So absolutely correct. See, I think you remember some stuff there. There you go. Okay, let's go ahead and take a look at 4 out of 16. What's 4 out of 16 here? 0.25, spot on, Schwal. Completely agree. So that's a straight up cool 25%. Okay, so that's all the scores in the 70s. The 80s are pretty much the same as the 60s, so we'll just reiterate what we have up there, since same three. So all right. We have 18.75 here. Okay, no problem. And then finally, let's put in 5. All right, so let's put in 5 here. So 5 out of 16, 0.3125. Okay, great. All right, so this will be 31.25%. All right, perfect. All right, nice job, everybody. All right, now one of the things that's important and why I decided to write it in these two ways here is because of the fact that if we add up all these decimals here together, adding up all these decimals here together, this would equal 1. Okay, or if you add up the percentages, this will be 100%. Now I am going to add a little bit of a side note to this though, so that way to keep things as realistic as possible in relation to this. So again, it should add up to 1 or 100%, but sometimes it'll be approximately 1. Okay, so let's go ahead and write that down here. So note here, the sum of the relative frequency could be approximately 1 if you have to round the decimals or percentages. Okay, so if you have to round because let's say, realistically, let's say the decimals there are super ugly to look at. All right, they're really really super ugly to look at because they just look awful. Okay, well then that's certainly possible if they're super ugly to look at. All right, and you round to like maybe 2 decimal places. You may round to like 4 decimal places only. And instead of getting some nice clean numbers, and then it'll be close to 1%. It might be a touch over 1%, might be a touch under 1%, or 100%, or 1. So that could easily happen. But yeah, that can happen because you just have weird numbers at the end of the day. All right. All right, so that is going to be essentially, that's how we answer question 2 and how we also set up our relative frequency distribution. This is also the answer here to number 3 about how we can actually construct a relative frequency distribution in this instance. All right. Okay, are there any questions so far about that? Any questions? We're going to work more with this example here, obviously, but any questions so far? Hey, it's James. Yes. All right. James, how you doing, buddy? Looks like we got the crew back. I know it's a little bit hello to you. I know it's way past your bedtime. But welcome, welcome. We're learning some statistics there. Everybody, this is everybody. Milky Jade and James come from James's channel. James's channel is one of my is actually my favorite channel here on this platform. Um, there's a lot of positive vibes. He's a super fun dude. He does a lot of different things. Does a lot of different things for hashtag United. He also does some editing there. He does some graphics work. He's kind of an all around nice dude. All right, so one of the best guys I know on this platform. One of the best, seriously, one of the best guys on this platform, and probably one of the nicest guys on this platform as well. So much respect to you. I'm gonna put a couple links there. I think you deserve that one. You definitely turn around. You definitely turn around some days there with your positive vibes, buddy. So I really appreciate you. So definitely want to say that there. So I'm just glad I can pass off those positive vibes to everybody here on this channel. That's really, really super awesome. So gonna tear up, hey man. Every time I know I come in for sometimes for just bursts of minutes and stuff, but every time I can, it's like I can watch Tesla today, and I can be really sad that my bank my accounts are gonna be very sad in the morning. But I can't be sad because of the fact that there's still people out there who are gonna support you no matter what. Good things, bad things. We all go through it together. Well, so just like the class we have here, learning about statistics. Um, you know, uh, we're one big happy family. We're going through it all together here. Pandemic. That's what we do. So that's what we do. You know what else we do? We consolidate data. You know how we consolidate data in these data sets? To be honest, that was a smooth segue there. What type of graphs can we make using frequency and relative frequency? Let's talk about that. Well, some graphs that we can certainly make here using frequency and relative frequency. I love you, James. You're great. Um, uh, some graphs that we can make here are bar charts. So we can make bar charts here. That's most definitely true. We can make line graphs. So line graphs here, pretty common here. We could talk about. Let me actually put that. There we go. That's better. We could put Pareto charts. Pareto charts is just a fancy way, just super fancy way of a ascending bar chart, so an ordered bar chart. It's just a super fancy thing. Um, pie chart. I think most of you have seen pie charts. Pie charts shouldn't be overall that new to you. Okay, so pie charts are like, yeah, there's a pie. It's made up of slices. You could put it in terms of its relative frequency or its frequency, and then the pie will be proportional to that, whatever that proportion may be. Okay, so we're going to take a look at, of course, some of these charts here and seeing how to organize our data in other visual representations. But you see exactly how things are going to work out at the end of the day, or at least how we can visualize and organize our data in things that we're pretty comfortable with, or at least seen at least once. All right, um, nothing too fancy going on here. Okay, now let's talk about one very important thing here. All right, and that's going to be the next kind of couple of questions. Now, I constructed this chart here. I'm going to go back and kind of split screen the example here once again. I'm going to again clue in on the classes that we have here, the categories that we have. Again, we put the categories here as the 50s, 60s, 70s, 80s, and 90s here respectively. And for us to understand about the class here, okay, i.e. categories, it's for the first thing we need to do is make up some definitions here regarding in relation to each one of these categories slash classes. First of all, it talks about the lower class limit. What is the lower class limit here? The lowest class limit here is going to be the lowest value in the class. So the lowest value in the class here is going to be the lower class limit. So again, here, if you look at 50 to 59, your lower class limit will be 50 at the end of the day. Simple enough. Upper class limit is exactly the opposite, okay, is the highest value in the class. All right, easy enough. Okay, now, the last thing that we want to look at here is class width. And the reason why I'm focusing so hard on what class is because of this last concept of class width. This is actually going to have some interesting consequences when we look at the next question here. So what is class width? Well, class width is a formula associated with it. So class width is going to be the lower class limit of class number 2 minus the lower class limit of class number 1. Now you're probably saying, whoa, 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 wait a second. Time out. Time out. Back the train up a second. That doesn't make any sense. Where is this class 2 and class 1 stuff come into play? What is this stuff here? I said, okay, that's fair to ask. All right. So the way class 1 and class 2 works in this definition here is basically going to be two consecutive classes. Okay, so I could say, for example here, let's take a look at our example that we have here. We're going to say class 2 here is going to be, this is going to be class number 2 here. And I look at the lower class limit of class number 2, which is 60. If I look at class number 1, that's going to be the class or category right before it, which is the 50s category. But again, one thing to keep in mind is that I can't skip categories, okay? I can't skip classes. I have to pick two consecutive classes in order to get in order to actually factor that into my class width. So in this case here, let's talk about what class width is. Okay, so if we look at our example here, XX, thank you for the follow. All right. All right, so class width here is going to be 60 minus 50. All right, so that's going to be equal to 10 at the end of the day. That's the class width of every single category. Here's here to follow? Wonderful. I just hope you learned something along the way, my friend. That's all that matters. All right. Okay, so why is this so important here? Well, one of the common misconceptions is when you're making up a category is like if you look at 50 to 59, you think that there's 9 scores within 50 to 59. You do like, oh, well, it's 59 minus 50. But in reality, the class width is actually 10 and not 9. And that's why we take the lower class limits of consecutive classes. So for example here, how many scores are between 50 and 59? We just do some easy manual counting. That'll be 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. So there are actually 10 scores in that particular class. Okay, so um, do understand that that did come from the fact that we confirmed the class width here by taking two consecutive categories as opposed to within just one. All right, so that'll be kind of a big deal here as we look at this next question. All right. So if we're trying to organize data here, the one thing that you unfortunately cannot do is you can't be lazy. Um, Math is one of those things that doesn't really allow you to be lazy. It can allow you to be lazy in some instances. In some other instances, it's not actually the best idea to be super lazy. And because, ah, shucks, I'm very lazy. Well, let me point this out to you here, Milky, and everyone else for that matter. If you're lazy in this process, unfortunately, you'll actually create more work than what's necessary. Sometimes when you think you're trying to be convenient, you actually make it harder for yourself at the end of the day. This is one very good example about where that actually happens. So, exactly what am I talking about here? Well, how do we construct a frequency distribution with the proper number of classes? First of all, we do have some guidelines here regarding the max number of classes. The max number of classes probably should be hovering around 15. Okay, so 15 classes is typically the max number of classes. Typically, when you get beyond 15, then it tends to be more clutter. Okay, at the end of the day. All right, so it tends to be much more clutter at the end of the day when you have more than 15 classes. That's just a generic tip that we usually take to the bank there. All right. Uh, the next thing that we want to do, and this is the part where you could easily fall into some traps here. So this is why I put down this next one here. Is that do not have a class for each individual data item in the data set. So one common mistake people say is like, okay, I'm going to have a class for 67. I'm going to have a class for 83. I'm going to have a class for 92 because all I'm going to do is I'm going to put a frequency of 1 and then I'm done. And then I'll be like, nah, because that's just not how it works. Like, I'm sorry, but you can't actually do that. That's unfortunately not true. Now, let's talk about why that is. Why do I state that here about not to do that here, even though I've seen that many times before? The reason why I state that here is actually because the last thing here is that each class must have a consistent class width. Okay? What this means is that there is no skipping. Okay? You're not allowed to skip when you make a frequency distribution. And that is especially true for your classes. So basically, I have to have the same class width regardless. So I have to say if I do 50 to 59 here as my first class, well then my next class cannot be say 60 to 64. That's not possible. If I have one class to be a class width of 10, the next category or class has to be a class width of 10. The next category after that has to be a class width of 10, and so on and so forth. All right, I can't just randomly skip around as I please. That's not a way we can actually organize data. So I can't say, "Oh, I'm going to put a category or a class for 67, but then I'm not going to put any categories for 68." You got to put those in. If you're going to take it one at a time, you got to put in one in. So instead of what you thought was going to be like consolidating it down to like say 13 classes because you're skipping around, instead you have to literally go from 50 all the way up to 99, and you have to put every single number in between. So instead of 15 classes or so, you actually have 50 classes, 50 classes. And that's way too much to do when you're actually organizing the data at the end of the day. So that's something that you absolutely want to avoid at all costs. Alrighty. Are there any questions about that so far? I hope that made sense. Any questions? Oh, now Natty's got 3 O's instead of 2 O's. Okay. We're falling further down the pit. No purr. No purr. No purr. Exactly. Exactly. You're like, why you teach this subject and why is it painful for my head? Oh my gosh. Oh, good. I'm glad you're getting it, Milky. Very good. Instagram stuff will be upcoming next. So, all right. Statistics, weird champ. Oh, I don't think so, my friend. I think stats is pretty fun. Calculus, PogChamp. Okay, if you're doing calculus, there you go. I can respect the game. Calculus can be a little bit well, calculus 2 is actually rather tough. I ain't gonna lie. Calculus 2. Um Calc 3 is Calc 3 is I don't know who you are. I'm a professor of mathematics. I teach up to Calc 1. So, uh I'm teaching here in college. Oh man. I know. I can't even believe it either. You never learn calculus. That's all good. You know, Calc 3 is okay, so if you want to go in order, Calc 1's the easiest, Calc 3 is the second easiest, Calc 3 is the second easiest, and Calc 2 is the hardest. Calc 2 by far and away is hardest of the three. It always goes in that order. Calc 1, Calc 1, Calc 2, Calc 1, Calc 3, Calc 2. Always in that order. That doesn't make sense. Well, the issue is with Calc 2. Yeah, sequences and series are really make that fairly difficult. With Calc 3, it's like a rehash, only you're doing it in like 3 variables. So you're using the same techniques that you learned in Calc 1 with a few more things sprinkled in. But in my estimation, Calc 2 is a big deviation from that of what you did in Calc 1. You're still using the concepts of derivatives and whatnot and integrals and stuff, but it's a big kind of shift away from what you learned in Calc 1 in some regards. So Calc 3 is just kind of like that, kind of like a reiteration a bit in my estimation. Jake, thank you for the follow. Appreciate that. Phasmite, thank you for the follow. Appreciate you. Yeah, we're talking about statistics right now, my friend. We're gonna do a histogram right now. Let's do it. Chin, thank you for the follow. All right, well, let's do it right now. I think that's not a bad idea. Everybody's kind of waiting on it, so I'm like, okay, that makes sense. All right, so let's take a good look here at the next question. All right, welcome to Twitch, where we're doing class. We're actually doing a class. Yes, I have no idea who else is doing a class here on Twitch. I know that in my college, I think I'm the only one doing a class on Twitch because everybody else uses Zoom. So, but I don't like Zoom, so I'm like, no, I'd rather do it on Twitch. So, yeah, Zoom, you have to face a camera toward your face and be like, there you go. Um, I'm not a big fan of. I want to give you guys, a sense of privacy. Obviously come here on Twitch and but you can still remain anonymous. You can relax here, and there you go. Am I drinking olive oil? No, I'm drinking some unsweetened bold green tea. There, Chin. Got some green tea and olive oil, man. I'll tell you that goes down the throat rather smooth. I got a 2-liter bottle of bold green tea here I bought from the Japanese supermarket. So if you're gonna do anything good with olive oil, here, here's a very popular thing if you ever go. So just have olive oil. Just like if you have a plate, just take a plate. Just take olive oil Olive oil plus some Parmesan cheese. And use it as a dip for bread. Simple enough. Olive oil plus Parmesan cheese, and then you use it as a dip for bread. Easy peasy. We have 50 minutes left. I'm so sorry. It is pretty legit. It is legit. Absolutely. Totally legit. You get some like nice French bread so you can like dip it in. You put the soft stuff in. Or just get Italian bread. Exactly what it's made for. There you go. You got yourself a winner chicken dinner. We're learning to eat olive oil now. Hey, we're learning practical applications. Okay? This is very important. Very important. Can you get into OGIVs now? We're not actually going to spend a whole lot of time on OGIVs, to be perfectly honest. Because you still Crispy GME to the moon. I don't know. I don't know what to tell you there. I don't know what to tell you there. GME GameStop sitting at 291 post market. So 291 post market. I think that the guys over at you bought at $42. I'm very proud of you. You've done better than me. I didn't even buy buy the GameStop while it was going up like crazy. So it went up way too fast. What's Bidmass there, Milky? I mean, I don't think I've heard of that. But while you're telling me what that is, oh, European PEMDAS. Okay. Okay. Yeah, European version of PEMDAS. That makes sense. Brackets would be parentheses. Indices would be exponents. Let me ask you guys a question here. Let me ask you guys a question before we move on here. What would be the answer to this question? Let me put this down here. What would be the answer to this question? Yes. One of those two is correct. I won't lie. Chris Crispy, thank you for the follow. Appreciate it. Bidmas 9, PEMDAS 1, right? Well, I'll tell you the answer here. What is the real answer here? The answer here is going to be absolutely 100%. The answer is 9. The answer is 9, regardless if it's the European way or regardless if it is the American way. They both are exactly the same. Okay, remember that multiplication and division, you have PEMDAS here. The best way to think of it is multiplication and division are the same rank. Okay? So multiplication and division are the same rank. If you did, let's say you had it instead of division multiplication, let's say you had 6 plus 2 minus 3, okay? If you did 6 plus 2 minus 3, you would add left to right here, right? You would say 6 plus 2 is 8 minus 3 is 5. This is what you would do. You would go from left to right. Well, you would do the same exact thing here because you don't have any brackets or parentheses to do first. There's no exponents of which to do, so those are thrown out as well. So you just go from left to right as well in that particular example. That's exactly why I actually write that out, because some people have the bad habit of being taught one of those operators has to come first before the other, which is not true. You actually take it the same way you do addition and subtraction. It just has higher priority than adding and subtracting. So, but they are the same priority. They have the same rank. So if you think about it in that way, that's why it's 9 and not 1. So, yeah, just one of those things to kind of keep in mind, um, as in terms of an order of doing something there. Yeah, I find that to be important because sometimes you're taught something one way, but in reality, it's actually the other way. So it's just kind of getting out those habits there, so that way you're looking at it in the correct way, with the correct perspective. That's why half the people who do those Facebook math things don't know exactly what they're doing. So they need to do order of operations. I teach here in the USA. Um, bam. Um, all right. What is a histogram and some properties? All right. So what is a histogram and some properties? All right. So first of all, let's talk about what a histogram is, and then we're going to construct a histogram based on our example here. A histogram here um, are there futuregrams? Now there are. I mean, I didn't see that coming, but now that you've already defined that, that's fine. I mean, maybe we could talk horoscopes. Those would be like futuregrams. All right, perfect. Um, but a histogram here specifically is a connected, and I'll specify connected here, connected bar chart that can represent the frequency or relative frequency distribution. All right, this can actually act as either or, and that's perfectly fine. All right, I'm going to talk about a property here in just a second, but again, we can talk about let's take a look at how we can construct this histogram here, and we'll see exactly how it will work. All right, all right. You forget math rules your life, Plasmite. That's just how it rolls, my dude. There's no money without math. Let's not forget about that. There's no industry without math either. But if you don't like numbers, I'll be happy to take your wallet and any other numbers that will be personal identification, and I will use it and exploit it to my pursuits. I'll be happy to take it off your hands. You got a social security number? Ha ha ha, I'll take that. Credit cards, no problem. I got it. Cash has numbers. We'll take. Easy. So good. That's a good joke. That's a good joke, Chid. I like that. You mean exploiting people using mathematics? Holy smokes. I don't actually want to know it. People can use that information in not so nice ways. If put in the right context, of course. All right, let me write the categories here, or the classes, I should say, for our scores. That's going to be down here. And then on the left-hand side here, we're going to put the frequency. Okay, so we're going to go by ones here. So we're going to go, again, 1 to up to 5, since 5 is our highest frequency here in our frequency distribution. Okay, so the way we're going to go ahead and take a look at this is, let's take a look at the 50 to 59. So according to our frequency distribution, there is one data item, one score that is between 50 and 59. So the way we actually construct our histogram here to start off with is, we're not going to start all the way off here to the left. Instead, if you notice the tick mark that I made here for 50 to 59, we're going to go a little bit to the left of that tick mark there, and we're going to start moving up. So we'll move up here to 1, and then we'll go up a little bit to the right here of 50 to 59, and this will be our first bar here. Now remember, the histogram here, pardon me, is a connected bar chart. So we're going to want to have all these bars here connected together to properly make this go. So what does that mean here in this case? In this instance, if we take a look here at 60 to 69, we have 3 test scores here that are between 60 and 69. So I'm going to start here on the upper right-hand corner of this previous bar. I'm going to go up to 3, and go slightly to the right of that 60 to 69, and I'll bring that back down. All right. And then finally, I'm not finally. I'm gonna continue moving forward here. I should say. All right, so I'm gonna have 4 here. So I have 4 between in the 70s. So I'm gonna make this up to 4. I'm gonna go ahead and bring this down here, just like so. Okay. All right, and then we have 80 to 89. 80 to 89 has 3, so we're going to come right here on the bar. We're going to see where 3 is on this edge here. So 3 is right about here. We'll go a little bit to right of the tick mark there of 80 to 89. And then finally, we have 90 to 99, which is 5. So starting from the upper right-hand corner, we're going to go up to 5. Go slightly to the right of that 90 to 99 hash mark there. And then there we are. Okay. No, maybe purple. All right. So this here, as you can see, is the histogram for this particular frequency distribution. All right. All right. So now we've properly constructed the histogram here in this instance. However, there's a little bit more that we can actually acquire here from the histogram in order to get this thing done and dusted, at least additional information here. So I'm going to just go ahead and put that here on the handout. All right, so let's put a note here. What you can also acquire here pretty easily from the histogram is you can also get the frequency polygon from the histogram. Now, of course, the question really becomes is, what is the frequency polygon? Okay, so the frequency polygon is basically a line graph of the frequency distribution. Okay, it sounds super. It sounds super. It sounds super complicated, but in reality, it really isn't. All right, let me go ahead and make this a half and half here. So Oh, brother. Politics, no. All right. Um, I don't want to do politics. Oh, yeah, yeah. Um, Politics and stocks are already complicated enough as it is. All right. So let's look at 50 to 59 here. The reason why I have these hash marks here, specifically where they're located, is because of the fact that I'm just going to make a little dot here in the middle of each of these bars here. Okay, so I'm going to mark this in blue here. All right. Low key, low key game stuff. Oh, thanks, Phasmite. Appreciate you. Okay. All right. We're gonna put little dot marks here in each of the middle here of these bars, and all we're gonna do here is just play connect the dots, and you don't have to. You don't have to go. You don't have to like do it, as a curve. You can just do sharp lines here between each of the points. So you could put a sharp line here, put a line here, line there, and a line that goes up like this. And this here, this is the frequency polygon here in blue. That would represent also another way to represent the frequency distribution. Okay. Uh, Steven Stokes, how you doing, buddy? You're up late. I hope you're doing well, my friend. All right. Are there any questions about the histogram or frequency polygon here? I'm doing very well, my friend. Very, very well. You can't sleep? Good. Maybe you'll learn something a little bit. I'm not here to bore you to death. I promise you, though. No. Nope. Okay. All right. I'll move forward unless there are any other questions here. Just this one. Yep. Bye-bye. All right. All right. All good so far? Perfect. Okay. Excellent. Okay. You guys don't mind if I forego a break here today? We don't have much further along to do, so I'm pretty sure I can knock out the rest of this lecture here. If you guys don't mind not taking a break today. That works? Yeah, look. Hey, look. You guys democratically said previously we would take a break, usually in the middle, but you know what? I want to ask first before I go ahead and do so. So, okay. If you guys give me permission, okay, that's good. Okay. Well, let's take a good look here at number 8 then. Number 8 says, "What are stem and leaf plots and what are some things to remember?" All right. So let's talk about stem and leaf plots here. Now, in this particular instance, instead of looking at a frequency distribution, a stem and leaf plot is going to represent the data set, specifically the specific data items in the data set. So stem and leaf plot here will represents every data item in the data set. One of the things that you can kind of take to the bank here is how you define the stem and how you define a leaf. A stem could be like the first digit, okay? So the first digit. So like for example here in our example, it could be the tens digit, okay? Um, the leaves here, leaves here could be the second digit or whatnot. Um, so second digit, or again, our example here would be the ones digit, since we're talking about test scores. And one other thing about the leaves here, I do want to make a note here before we put this together, is that you can repeat leaves. Okay, so because every single data item in the data set has to be represented, even if they repeat. Okay, we're not just putting it one time; we're actually putting it as many times as we do see it in the data set. So we may see the multiple of the same numbers in a stem and leaf plot. All right. So what exactly does that mean? All right, remember, no skipping as well, even if there's nothing in that category. Can't skip. All right, same thing with like classes, you can't skip. All right, but let's take a good look here at our example once again. And let's go ahead and make a stem and leaf plot here. But this time I'm going to scroll over here to our data set specifically because we want to look at those numbers there. And we want to go ahead and arrange the data in a stem and leaf plot sort of fashion. So we're going to put a stem here. And here we're going to put the leaves. So let's say the stem here is going to be our tens digit. So we had 50, we have scores in the 50s, 60s, 70s, 80s, and 90s. So the stem here is going to be 5, 6, 7, 8, and 9 to represent 50s, 60s, 70s, 80s, and 90s here, respectively. And all we need to do now is just go down the list here. Okay, so if we just take a look here at 67, all right, we have 60, and then for our leaf here, we would put 7. So this would represent 67. And so you see the next one here is 83. So we have 80, and then we put a 3 as a leaf here. We have 92, so we'll put a 2 here next to the 9. 51, so we'll put a 1 here next to the 5. 99, put a 9 here next to this 2. So again, we have 92 and 99. We have 81. We're going to put a 1 here next to the next to that 3. So 83 and 81, again representing two different data items, two different scores. 77, so we'll put a 7 right here. 73, we'll put another 3 right next to that dude. Now we do have another 77 here next, but remember we can repeat leaves here, so we're going to put another 7, just like so. Okay, so again, we can repeat that number as many times as we want because we're representing every data item in the data set. 60 here, we're going to put a 0. Okay. 91, put a 1 here. 92, and repeats again, but it's fine. 88. 63, put a 70 here. And finally a 93. And so as you can see here, this is how we can put together a stem and leaf plot. All right. This stem and leaf plot here is fairly easy to put together. And again, you can see the same type of distribution that you have here for the histogram. All right. It's pretty much one and the same because you can see how many numbers are in each category, or it matches exactly how high the bars would be in each of the categories in the histogram. So that in effect is a stem and leaf plot. Again, yet another way to go ahead and organize your data in a very simplistic way. Okay, any questions about that? I'm gonna go ahead and make this half and half here. Left here, so you're still copying that down, that's fine. Okay. Alrighty. Stuff. So far, so bueno. Alrighty. Alright. Does it matter what order we need to put in for the leaves? You don't have to necessarily put it in numerical order, but if we need to find additional data there, Natty, then yes, ordering will matter. So if we're trying to find what we're going to be looking at here in say chapter 3 and whatnot is going to be if we look at say mean, median, mode, especially for median. Mean doesn't really matter, but median, we do need to have an ordered data set in order to find say a median of a of a set of data. So you'll probably will see future examples here that are actually already in order to actually figure out some additional information, right? So there will be a purpose of doing so, but you don't have to, for these examples here, you don't necessarily need to. Okay. All right, next, let's talk about some shapes of, yeah, no problem. That's why I'm here. I'm here to answer questions and help you out. All right. What are some shapes of distributions? Now we're going to look at four major types here, and I'm going to show you a page here. So let's talk about those four major types. The first one here is a uniform distribution. That basically means that all the bars on the histogram are exactly the same. So basically, at the end of the day, the frequency for everything is exactly the same, hence why all the bars will be exactly the same. So that's a uniform distribution. We have a couple more here. We have a skewed right. So a skewed right distribution is that the tail of the distribution, the tail of the histogram uh, goes, so it's kind of like a big long tail of a histogram uh, is is uh, is to the right. And we'll take a look at a picture here in just a second. We also have the other side here, skewed left, which is just the opposite definition. So tail of the histogram is to the left. And then finally, compared to those three, the last one that I'm going to put here is going to be the most important. And that is because of what it actually entails in terms of it's actually one of the most important distributions because it's the most ideal distribution that we want to work with. And that is the normal distribution. The normal distribution here works as, say, a so-called bell curve. Okay, all right. So it'll be like it's a bell curve and symmetric. All right. So I'm just going to point it out this way. It's a bell curve type shape type of thing. Here is the normal distribution only with bars, and it's symmetric in nature. Now, what does it look like here? Let's take a look at that here in the textbook. So, because the textbook has some good stuff here. Bring up the page here. No, it's here, but it's just a second here. There it is. Okay, perfect. All right. Okay. So as you can see here on the screen, each one of these represents the type of distribution here that we can run into. As you see the uniform here, we have the histogram here, being every bar is exactly the same. Again, the skewed right, you see the tail end here of this histogram is all flowing here to the right, and a majority of that stuff is to the right. Again, skewed left is just the opposite there. You see everything kind of tailing off to the left here. Um, and then, is this skew called this because when your median is to the right? Yes, that's correct. So you can see like it is very top heavy on one side or the other in terms of the frequency. But yeah, the actual tail end is just yeah, it's exactly as you said there, Milky. That's very well said. And then we have the bell-shaped curve, i.e. the normal distribution. They call it the bell-shaped curve here in the book, but in reality, it's the normal distribution. We're going to look at a lot of things revolving around this guy right here. So you notice that you have, again, you have a small amount here on the ends. You have a slightly higher amount, and then you have a slightly higher amount, and then a slightly higher amount, and then kind of the big one here in the middle. So it's like the old philosophy, a lot, very old philosophy is that what they used to do back in the day is a teacher would say that they made a fair test if the results of that test followed a normal distribution, that it was that was a bell-shaped curve. So a few people would get A's, a few more would get B's, most people would get C's. The same amount of people who got B's would get D's, and the same amount of people who get F's would have got F's would have this be equal to the same amount of people who got A's. So it's like, okay, that's a fair test. That's a good test to make. Do I follow that philosophy necessarily? The answer is no. But again, that was a philosophy that was made quite a while ago. Um, and bell-shaped curves or normal distributions were used in order to actually met that out. All right, next here, next part here. Okay, so the last question here, at least as part of this handout anyway, is talking about a time series plot. I'm not going to talk about this too much here. I'm just going to define it and kind of move on. But what's a time series plot here? Basically, this is a plot, like basically a line chart of some variety, uh, that plots over time for a variable. Okay. The book has a pretty solid example here. So let's just take a look at that here. Like I said, I'm not going to be like super stressed on this one here. I forget that the pages are a little out of order. Uh, that's a dot plot. I know it was here somewhere. This is what happens when you give me one textbook. All right, let's just look what. All right, so this would be like if we talk about stonks here today. This is basically a time series plot kind of graph. All right, so this measures, let's say, the number of quakes over a period of time, and they talk about an index here. Whatever the case may be. Uh, what's the price of a particular stock over time? 52 weeks, for example, a a year. There you go. That'll be like a time plot essentially at the end of the day. All right. Okay. Okay. So we have that. All right. Any questions about that? Any questions? Steven's like, no, perfect. All right, cool, cool. Nop indeed. All right. Okay, so again, type no in the chat if you have no questions. That way I know when to move on. Or if you do have a question, go ahead and type it out now. No, yeah. Can I scroll up really quick? Yeah. Yep, sure, sure. Give me just a second here. There we go. Let me know. Let me know once you got that. Once you got that in your notes there, and then I'll move forward. Okay. Will you be doing Jesse's stream tomorrow? Yeah. So Jesse's stream will be tomorrow at 6 p.m. English Standard Time. So for English Standard Time, not here, but be 12. It'd be noon my time, 12 p.m. your time in England. Or yeah, noon my time, not 12 p.m. in England. Noon my time, 6 o'clock in England. Yes. We'll be doing a special stream tomorrow on financials and stuff. It's a good time to talk about the stock market and stuff, considering it's all the rage in the news. So, but we'll be talking about some basics and whatnot, and possibly LP might join us as well. So, we'll see. That'll be noontime tomorrow, noontime Central, 6 p.m. England, English Standard Time. So, if you come by noon here to the stream, it'll be after my initial class there. So my initial class got to take priority, and once I'm done with that, there you go. 6 p.m. GMT. All right, and 12 p.m. Central Standard Time. CST. All right. It'll be nice to have a nice fun stream, just kind of chat it up and stuff. All right. Okay, so we're going to look at one question here on the next one. Now, section 2.3, admittingly, um, this does talk about, let me go back here to the book for just a moment. Apologies. Okay, so section 2.3 does talk about the, as stated here, relative frequencies and whatnot. Um, it does talk more about that. And so with the relative frequencies and whatnot, you can look at average relative frequency. You can arrange it in terms of a stacked relative frequency or whatever. The ogivs that was mentioned earlier, that's where you can find it in section 2.3. I'm going to go to page 100. Um, but some of that stuff here, at least for what we want to be doing here in the course, is not going to be super relevant, at least for some of the objectives that we want to establish. However, if this is basically kind of, if you want to pare it down into something, this is basically reading like line charts, okay, of some variety, like saying, if you want to interpret this, it says, what's the approximate class width? Okay, so you'd say, okay, the approximate class would be like 2, like 1 actually. So if you're taking a midpoint between, let me that be. Oh no, it'd be 1 actually. So you'd have it'd be 2 actually. So here you have again, 1.9 to 3.9, 3.9 minus 1.9. You see, what's the approximately 92% of all tornadoes are less than what length? So you'd actually add up your cumulative relative frequency. So you'd see where 0.92 would be approximately. That'd be right here. So again, they're less than 11.9 miles. Sure. Okay, so really that's kind of like reading a line chart here. I know I'm kind of like briefly just kind of skimming it very quickly. But in reality here, for this, for the objectives that we want to be going over here, I'm not going to go into too much detail in regards to this particular section. So you could go ahead and read this over here. It really isn't too hard to do. Now that we've done an example here with lower class, upper class limits, it should be pretty easy to kind of figure out anyway. Just kind of reading off the line chart there, that instant. All right. Now, let's go ahead and talk about here the. I just have to do one more question then. All right. So The last question that we do want to talk about here is we want to talk about how can graphs be misleading? How can graphs be misleading? So, the one thing I can say about how graphs can be misleading is one thing you have to be very careful about is anytime you have a set of data, numbers, let's not forget, numbers can lie. All right, numbers can lie. This part is actually true. All right, and the reason why numbers can lie is because it depends on how you calculate them. All right. So you have to have a pretty good solid calculation. And the one thing you want to do is to have it basically be free and clear of bias. If it's free and clear of bias, then the numbers are not going to lie. The numbers are going to tell you the truth. But if you omit some stuff there, then maybe that's not going to be the best way to actually present your the data there in a non-objective way. All right. There are many ways that graphs can be mismanaged. Okay. Few things would be scaling. That would be one thing. Um, Incorrect percentages. That's another way. Let me go ahead and show you here, since we're on the interwebs. One of the things that I can show you here are some classic examples of misleading data. So, talk about. This is one of my favorite ones here, in all honesty. So this was actually done in 2012 during that presidential campaign. So if you take a good look here, this is a pie chart here. Let's look at this pie chart. Okay, let's all take a look at this pie chart that we see here. Can anybody tell me what's wrong with this pie chart? Look at this pie chart. This pie chart is remarkable. I'm going to be honest with you. This pie chart actually 150% for the win, right? It might be more than 100%, right? It doesn't equal 100, that's for sure. 100, that's very true, right? I mean, I've never had three candidates that nearly 200% support. That's just that's pretty remarkable. Pretty remarkable indeed. That's very remarkable. There's a few more here that actually are rather interesting. Um, Actually, I want to talk about this one here as well. Um, so here, it's not all about Fox News necessarily, but other stations use the same kind of deceptive practices. So I'm not going to just pick on one place. Um, but this talks about the unemployment rate underneath at least in this case in 2011 underneath President Obama. All right, now if you take a look here carefully, the deceptive parts here is that, as you see the lines that are drawn here, is that 8.8% somehow is less than 8.6%, which makes no sense, by the way. Yeah, you can see how that's kind of deceptive there, where the scaling is way incorrect. All right, extremely incorrect. Let's see if I can bring that up here as well. Okay, let's take a good look here at. I know, right? I want to show you one more here. Now, this last one here is actually in relation to this graph here, though not a Fox News related graph here. It talks about the unemployment rate. Okay. Oftentimes you hear in the news regarding the unemployment rate. The unemployment rate talks about saying, how many people are out of a job, at least the percentage of the country or percentage of possible working people. Let's take a good look here at this site here really fast. This is shadowstats.com, but this provides a good objective analysis about what the actual unemployment rate in the United States actually may be. So, in this case here, the red line here is the official government statistic for unemployment. The shadow stats one is kind of is a much higher version of that particular number. And then the broadest one here would be kind of like, somewhat, I won't say exact, obviously, but a somewhat of an average between the two. So the official one here is obviously when the pandemic hit, a lot of people lost their jobs. And that was rather unfortunate. And then as we see here, the current unemployment rate is currently sitting at, looks like close to 7% or so. Okay. Looks like it spiked up to 15% at one point. According to Shadow Stats, that could have spiked up to 35% during the height of the pandemic last year. All right. And now is sitting roughly above 25%. Now you're probably saying, whoa, 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 time out. That's a very drastic difference between 7 and 25%. All right. And you're probably saying, okay, now which statistic is actually true? Well, here's something that's important about unemployment here in the United States that is some that you do have to keep in mind. It basically comes down to how you actually calculate the statistic itself. Think about people who haven't looked for a job. Those people, after a certain amount of time, let's say you lost your job and you don't go back to work for like 6 months and you're not really actively looking. Those people no longer are included as part of the calculation for unemployment. Okay? So, therefore, you can artificially take away people from the actual calculation for unemployment to make it look like that the unemployment numbers are actually lower than they actually are. Now, do I believe it to be near 25% or more? The answer is no. I don't think it's near 25%. I think it's definitely between the two of 7 to 25%. I think it's actually much more realistic to say it's actually somewhere in between. But this is a way you can manipulate the data in order to get it to work toward a narrative that you're actually looking toward. So if you're saying, "Oh, look, unemployment numbers are down," let's say you're politically, "Oh, look, unemployment numbers in my district are down." But then you have to ask that guy the question, "Well, how'd you come up with that number? Tell me how you come up with that number. Show me the calculations." People who are homeless, they're not included in these calculations underneath the government statistic. Veterans, and not older veterans, but younger veterans, the ones who have left the military and whatnot, they're not included in that calculation either. So some of them are not included at all. Let's say people who are like house husbands, housewives, sort of deal, who are not actively looking for work. Those people are not included in the calculations as well. So when you talk about, say, how things can be misleading, that is definitely a way where you can actually see for yourself that, yeah, there's an actual distinction there in that instance about where numbers can certainly not be as accurate as you thought it would be. Let's see here. And if you want a good old macro approach here, let's look at the whole macro approach. If we're talking about the United States and its current state of the economy in terms of like relative numbers, then you can go to usdebtclock.org and you can actually take a look here and see what the current state of the economy is in from a big picture perspective. So as we can see here, the US national debt here is $28 trillion. All right. So um yeah. Yeah, there you go. This breaks down to like a lot of different places. So this actually break it down state by state as well. Yeah, so this is actually run off of a linear model, or actually models that would model how much money we're spending every single second of every single day. So yeah, this will add millions like it's no tomorrow. That's true. Yeah, maybe your macro professor. Show your macro professor this, be like, yeah, this is kind of bad. Um, if you take a look here, like the debt per citizen is $84,100. That's the same. That basically means when you're born, you already owe $84,100 in debt. Ain't that amazing? You wish your bank account? Me too. Me too. The biggest issues that we actually have here, um, F in the chat, boys. It's true. F in the chat. Um, the biggest issues that we actually have are actually numbers that you'll actually see here toward the bottom. If you want to understand exactly how things are overall from a big macro perspective here, I'm going to turn your attention to these numbers down here. These two numbers here are things that people talk about quite a bit. For example, here, Social Security liability. Everybody pays into Social Security here in the United States. Okay, if you work, you get to put money into Social Security. When you retire, you'll get money from the government in terms of a pension. How much do they currently owe in Social Security? The government here currently owes nearly $21 trillion in Social Security. Okay, that's how much liability that they currently have and continue to add as people are moving closer to retirement and have to dole out them checks. $21 trillion is quite a bit. Okay. Second thing is Medicare liability is again, of course, taking care of the health of the seniors and whatnot. This is $32 trillion worth of Medicare liability, as we know that medicine here and healthcare are rather expensive here in the United States. So that's quite of a big amount of liability that you have. That's a lot of money that you actually owe at the end of the day. Even unfunded liability is $160 trillion. It's crazy the amount of money that you actually owe at the end of the day. Um, but the biggest issue with me is Social Security is that once you're your retirement age, the issue is that the amount of money you get back in Social Security, will it be enough for you to stretch that dollar for you to live every month from month to month, collecting those Social Security checks? That's something that's very important to know. Okay, your purchasing power when it comes to money is very important. Okay, so if you don't know how much how far you can stretch your dollar, well then it's going to be a little bit tough at the end of the day. All right, so want to stretch your dollar appropriately. Again, inflation is going to have a big effect about how far that can stretch. So again, that happens to be a big issue here. You can see credit card debt, $977 billion of credit card debt. Student loan debt, I know all of you love student loan debt. It's the best. $1.8 trillion in student loan debt. Okay. Everybody loves student loan debt. Yeah. You want a real F in the chat. There you go. That's the real F in the chat, student loan debt. Yeah, it's kind of a thing. Big F's indeed, yes. This actually does break it down by state as well, so you can actually go state by state as well. You can actually take a look here at states. Like we could look at Illinois and look at its specific one. So how many people are unemployed in Illinois? How many people get food stamps? What's the current GDP? What's the current debt in Illinois? Wow, that debt is idiotically big. So, yeah, it's not good in Illinois. Definitely spend more than we take in. So, all right. Apologies about that. Does anybody have any questions? Any questions at all about that? Illinois, Illinois, Illinois. Ay, ay, ay. Illinois. Illinois lost more people than California last year, which is crazy to say, but true. Nope. Alrighty. Good beans. Alrighty. Well, we're going to pick up from chapter 3 here for next time. Okay, that's what's going to be on the agenda here for next time, is going to be chapter 3. Illinois is the 101 how not to run a state. You got that right. 100%. You got that right. That is definitely not the way to run a state, ever. But No, I want to thank you guys so much here for coming out. I'm sorry for taking the full time here. I do apologize in regards to that. All right. Um, but yeah, I hope all of you have a wonderful weekend. Okay. The homework for the homework there is the redos unlimited. Yes. So if you try 3 times, you get it wrong 3 times. Just hit similar question, and you can redo that question with new numbers. That's about it. You can do it as many times as you want and get full credit for it. Okay, Natty? When's the quiz and test? Do we have a date set? Until we finish up Chapter 4. So Chapter 4, after we finish up Chapter 4, I'll be announcing the test, and we'll be talking more about that once we get closer to that time. Hey, thanks, Steven. You have yourself a wonderful night, okay, Steven? You stay safe and stay sane. Stay sane, all right? I hope to see you tomorrow. Then the homework isn't due till the test is announced. Yeah. So when the test is due, that's when the homework will be due for those particular chapters. So thank you, Pallet. I appreciate you. You have a great rest of your week as well. There's some terms in the homework that we didn't talk about. Will that be on the tests? No. If I don't talk about those terms, those will not be on the test. I curate the questions so that way I skip material so those little extra tidbits, yeah, they're not going to appear on the test. That's a promise I made to you, and I'll stick to it. Yes, that's correct, Camera. Right, the hard date would be until that test date there. No quizzes, just tests. Yes. No quizzes. Just tests. If you want to do a quiz on your own, then that's your prerogative to do like a practice quiz. That's fine. When we get to the test time here, there will be a practice test you can try as many times as you like to get comfortable with the test questions and whatnot. So I'll have that set up and ready to go once we get to test time there. Yeah, unless you want quizzes. I mean, quizzes. Yeah, that's what I wanted my whole life. No! Neurotic, hey, how's it going, my friend? Are you using StatCrunch at any point? Yeah, so there'll be points where you use StatCrunch. Basically use your calculator to do it. So if you have your graphing calculator there, we'll be using stats functions on your calculator. So that'll be super helpful for us to get the values that we're looking for. I'm doing really well, my friend. If you're doing tests, I'm just gonna lurk. Well, we're doing statistics tests on our calculator here. Our good friend the calculadora. So use the graphing calculator, bip bop boop on the buttons, bam, and then there you go. You got it. You're more than welcome, though, Steven, to participate and join in and ask questions. All right, Natty, thank you very much. You have a wonderful night. Ujwal, thank you so much. I really appreciate you coming out. Thank you very much. And by the way, Ujwal, thank you for the follow. I really appreciate that as well. You'll get push notifications about when I come online for our classes. You'll be here. Perfect. All right, everybody. I want to thank you again for coming out here to stream. You guys, Hey, look, I'm gonna take a loss here tomorrow. That's just the natural thing. But hopefully it's not gonna be too bad in the morning. We'll see. Hopefully I'm just gonna probably sell my positions in the morning. I'll take the L and then be like, okay, cool. It is what it is. So but I want to tell you guys, I want to thank you guys so very much for coming out here to the streams once again. You guys, yeah, I'm hoping to recover too, okay? It's not the end of the world. A few $100 here or there, I'm not going to be too sad. I was super successful last year, in all honesty, Camera. So I'm even happy to even have that. a kind of extra money in my pocket. So I'm not gonna sit here and complain a whole ton. So you gotta risk money at the end of the day. But not gonna be sad. It is what it is. But again, thank you guys so very much for coming out here to the stream. You guys are legends. I love you all. I hope to see you all here on Monday. All right. Take care of yourselves, everybody. Sit back, relax. All right. Stay safe. Stay healthy. And more importantly, everybody, stay sane. All right. Take care of yourselves, everybody. We will see you later. See you Monday, everybody. Have a good weekend. All right, everybody. Bye.